in
the
today.
temperamental factors
Another
that
beautiful
influence.
day. Um, Definitely. One thing I want to say that we don't have class next week because there is a spring break. Hopefully, it will be beautiful. You should get out there. Remember, as scientists, we're always interested in nature. I mean, the basis of being a scientist is a love for nature. Sure, we want to figure out the patterns and how it works, but that deep love of nature is seriously important. It can renew ourselves. Um, and I think just try to get out there as much as possible, if you have time. Um, okay, let's begin. We got Brady and Samuel up, and so I have their video they sent me, so we're going to play that. Before I do that, people are sending me lesson plans. Everyone's doing excellent. People are sending me lesson plans before their lesson. That's what I wanted. Um, they're pretty good. I think they're one thing that I would recommend is syntax. Syntax, once again, academic language. You know how I feel about that. Um, Definitions, vocabulary, and misconceptions are fine, but we have to do this to pass this exam. And the exam is $400. And so one of the easiest things to lose points is in the academic language section. So the ones I've seen, I've only seen 4. And I would say that the syntax, which is rules for writing and speaking. Okay, discourse is speaking, writing, and speaking. That's what discourse is, writing and speaking. Syntax are the rules for that. Okay, so you got to fill everything up. You got to fill all these categories up, even if it might be like a stretch, because I want you to show me that you understand it and that you're going to get full credit on the EdTPA. So when it comes to syntax, students will follow the rules for table making. Students will follow the rules for bar chart making. I mean, those are like, real de facto or conservative ones that you could just choose that if you can't really find anything. Okay. I'm looking just to like, yeah, you got to fill it up. You got to kind of complete it. Even if it's kind of tangential. All right. Because we're thinking about, I want you guys to pass this exam. All right. Obviously, when you're getting out on your own, there's going to be 2 type of lesson plans you're going to make when you're out on your own. Okay. One is one just like you made me, just like you're making at Hunter, like a 3-pager, and that's detailed. And so you want to have a nice, that body, that middle, you want to be descriptive in that body. All right. So I'm looking for 2.5 to 3 pages. These are the kind of type of ones that you give out to principals and APs that come and visit you. On a day-to-day basis, you cannot maintain that. Most people cannot. 90-something% cannot maintain that. So if you just do a page, 1 page when you're on your own, that would be wonderful. That'd be fantastic. Okay. A lot of people just give it up. And research shows that if you do a lesson plan, you'll have a better lesson. Okay. It's worth making. All right. So while you're at Hunter, and especially for me, especially if when you're in student teaching, when you're being observed, you got to give a really kick-ass lesson plan, which is what we're kind of doing in this class, which is like a 2.5-page, 3-page thing. All right. You guys have any questions? We're not meeting next week. And after that, we have Shirley and Wasim. Okay, Shirley and Wasim, how are you feeling about your lesson?
Is it okay if we just talk to you a bit after class ends?
Okay, good. Yeah. Okay, so let's meet up after class and discuss that. Any other questions about today? About anything off topic, on topic? Everything's cool. Okay, good. Let's do this video. So let me share screen. And let's pull this up. Okay, so once again, as you're watching this, right, take some notes, all right, because I want everyone to like, your job is to how to make, Brady and Samuel's lesson better than it is. What things do you really like? What things do you would like to change if you were doing it? Take some notes, think about all the different parts. One of the first questions I'm going to ask those guys, hey, is this a flex at 1, 2, or 3? Okay, where's your vocab? Right. So and then also, if you like things, steal it. write it down, incorporate it into your own lesson. If you already did a lesson, get a little notepad somewhere, a little book, and write down good ideas and put that in there. So this is like, there's been really some really good lessons with some really good ideas. If you see like a fun summative assessment, everyone's like flipping a coin. That's great. Digital flipping, little things like that really do matter. And so write it down. Keep that in a safe place so that you could use it when you're going full time.
This computer. Okay, we should be good. Okay. Hey everyone, how's everybody doing? Wasim, what's going on?
Not much, man. Just got done with some dinner. Not dinner, lunch. It's 2 o'clock.
Pretty good. Shirley, you done with dinner too?
Dinner was great. I even had dessert.
That's. Are you guys ready for a fun lab?
I'm super excited.
Super excited.
Good.
Actually
Okay.
excited, yeah.
If you guys were not ready, it'd be an issue because this is a very fun lab. So get ready. So we're going to be talking today about the period of a pendulum. And first off, I'm Mr. Richter, and teaching with me today is Mr. Rivera. Mr. Rivera, how's it going?
Hello, I'm doing well. I have my KFC iced tea right here, and I'm ready. I'm ready to do physics.
Excellent. So we have a little picture here of a pendulum. So you can see it's got a couple of key pieces to it. It's a wire or a string that's attached to a fixed point. And on the bottom of it, it's got what's called a bob, which is a little weight. It's kind of funny that it's called bob. So in honor of that, I'd like to introduce you to someone who's very important to me. This man in this white collared shirt is my Uncle Bob. He's actually my Uncle Bob. He's got no idea that he's featured in this presentation. But in honor of him, I'm going to name my Bob Uncle Bob. So we're going to ask you two to come up with names for your very own Bobs. And ideally, they should be some kind of Bob Robert type name. So just to give you some time, let's start with Mr. Rivera. What are you thinking for your name?
I'm thinking Sir Bobanel III.
He's a knight. That's excellent. Okay. Wasim, coming to you. What do you think?
I'm going to call mine Bobby Roode.
Bobby Roode. I like that. Okay, Shirley, what do you got?
Go with good old-fashioned Robbie.
Robbie. Very good. Okay. Give it to
Robbie.
Mr. Rivera.
Okay, nice. Thank you, Mr. Richter. So before we start talking about pendulums and bobs and all this great stuff, we need to draw on prior knowledge. So for the do now, I'm going to give you 30 seconds to think at what points on a swing is potential energy the highest and when is kinetic energy the highest. I'll give you 30 seconds to think this over. And then we'll start with Shirley. Okay, that's about 30 seconds. Shirley, at what point or points is potential energy the highest?
So my options are X, Y, or Z, and or Z.
Yes.
I think it might be the highest at X and Z, since that's stored energy. So they're about to go down or they're about to go forward. And then kinetic energy is the highest.
1 second. Very good. You got potential energy correct. Now, Wasim, I would like for you to answer, when is kinetic energy the highest?
I agree with kinetic. Sorry, kinetic is higher at the Y point.
At the Y point. Very good. Perfect. So I would like to hand this back to Mr. Richter.
Thank you. Okay. So as we all know, or we should know, the Earth is rotating. It's not obvious to us that the Earth is rotating because we feel like we're sitting still. It could be that the sky is moving around us. So how do we actually prove that the Earth is rotating? Well, a scientist actually went about doing exactly this back in the 19th century. This is Jean Foucault, and there's a picture of him. And I'd like to ask one of you, what country do you think Jean was from? Anybody have an idea?
The name sounds very French.
French. That is exactly right. This man was from France. So what he did is very interesting. He made a pendulum that today we call the Foucault pendulum. This is back in 1851. and this thing was gigantic. It was 67 meters high, and the bob, or the Uncle Bob at the bottom of it, was 62 pounds, or 28 kilograms. To give you a sense of how large this thing was, we're going to think about something we all know about, which is a football field. So let's go to Shirley. Shirley, do you, by any chance, know the length of a football field in feet?
About 300 feet.
That is exactly right. Where did you get 300 from?
About 100 yards. So that's about 300 feet.
Perfect. Exactly. So this wire is 220 feet long, which is about 2/3 of a football field. This would put you at around, I believe, the 27-yard line if you start the pendulum at the other team's end zone. And then as far as 62 pounds, that's about the size of an average 8-year-old. So if you imagine putting an 8-year-old at the bottom of a string that is that long on a football field, you've got the Foucault pendulum. So what happens if you release this Foucault pendulum? Well, it moves back and forth, as you can see in the little GIF here, as any pendulum would. But something interesting happens over the course of the day, which is the axis or the plane that it's moving back and forth in starts to rotate around the base. You can see it kind of pushes over this domino as it starts moving around the circle. Just to speed up this process, here's what it would look like over the course of many years, is you'd see this kind of rotation around the base. And you probably wonder, okay, why is this happening? As it turns out, the reason why this is happening is because the Earth is rotating underneath it. The pendulum is actually staying put. The plane that it's moving back and forth in is the same the entire time with respect to, I guess, space. But Earth underneath it is rotating, but because we're part of Earth, relative to us, it seems like the pendulum itself is rotating. So if you're on the North Pole here, it would take 24 hours for it to complete a full rotation around its base. He was in France, and it's a different latitude. So it's a different period of time that it takes to move in a complete circle. But this is the power of massive pendulums. We get to prove very, very cool things in 1851. So coming back to Mr. Rivera.
Thank you, Mr. Richter. So we have our aim here. Wasim, could you read our aim aloud for us?
No problem. Sorry, no problem. What determines the period of a pendulum?
Thank you, Wasim. So what determines the period of a pendulum? We have a few words in here that we don't quite know the definition of yet. So this is the vocab that we need to know for today. Our first word is pendulum. It's a body suspended by a pivot so that it can swing freely. Make sure to write this in your notes, please. That's our first vocab word. Our second vocab word is oscillation, the repeated back and forth movement of an object between two states. Good job writing this down. And our third vocab word for today is going to be period. It's the time for an object to complete one oscillation. Give me a thumbs up once you wrote down the 3 vocab words for the day. We got Shirley, Mr. Richter, and Wasim. Very good. So let's revisit our aim with these new vocab words. What determines the period of a pendulum? What's going to happen? What do we think? Can I get some hands for a prediction? Wasim.
So should I use the vocabulary we learned or in my own words?
In your own words.
Okay, so to determine the period of a pendulum, I think we might need to keep into account the size of the string, like in the case with the largest one they made.
Okay, size of the string. And by size, I'm going to actually change that word to length of the string, right? What do you think is going to happen when you change the length of the string, Wasim?
Oh, so I guess depending on how long or short it is, it might swing faster or slower, which is pretty much, I guess, the period, right?
Mm-hmm, exactly. So let's make that more concise. A longer string will make what happen?
A longer string will cause the period to be longer.
Will cause the period to be longer. Okay. So, do we have any other predictions for what might determine the period of a pendulum?
The weight of your bob.
Okay. The weight of the bob. I'm going to change that weight to mass of the bob.
Shirley, didn't you call your bob something else?
Oh yeah, the weight of Robbie.
Okay.
Weight of Robbie.
So if Robbie ate a lot and he's a little larger, he'll might swing slower. But let's say it was New Year's, he lost some weight, he might be lighter, so it might swing faster.
His New Year's resolution. I like it. I like it. Okay. So we have two predictions here. Very good. So these are actually the two conditions that we are going to test in our lab today, right? And we're going to need to prepare that lab. So we asked you to bring some materials to class today. We're going to go over them. So could everyone please hold up their 1 meter length of string? Very good. Wasim, very good. Shirley, thank you, Mr. Richter. Do we have a stopwatch or a phone? I have my phone here today. Wasim, very good. Shirley, good. Mr. Richter, good. Now, we also need a marker for today. Okay, very good. Shirley, Wasim, Mr. Richter. We need a ruler or a tape measure. I have my tape measure here today. Very good, everyone. We need our 4 quarters as well. My 4 quarters right here. Very good. Now, we need scissors if you didn't cut your string to 1 meter already. Wasim, very good. And we also need tape. I'm a fan of Mr. Richter's Scotch tape and Wasim's Scotch tape. I don't have Scotch tape. Surely that works too. I'm in the same boat as you. So now that we have all these materials, I'm going to hand this back over to Mr. Richter to walk us through our first part of the lab.
Excellent. We will be testing the effect of mass on our period first and foremost. So here's what we're going to do. Step 1, take your meter-long string, and this is actually a step we're going to take that prepares us for the second part of our lab. We're just going to go ahead and do it right now. We want you to mark increments of 25 centimeters along your meter-long string. So at 25 centimeters, 50, and 75. You can use your ruler. In case it's not metric, we do have measurements in inches there. But a little shortcut is actually if you bend your string in half and find that halfway point, you can put a marking there. And then if you bend half of it in half and then find your halfway point there, you can also do it that way. So either way is fine. Give us a thumbs up when you are done marking your string. Is that a thumbs up, Shirley?
Yeah.
Excellent. It's like we're waiting on the scene.
Sorry about that.
Take your
So,
time, and you're good.
so it's 1 fold and then just 1 more fold, right?
Yes.
Okay. So
All good. Awesome. Great. And we are moving to step 2, which is take 1 quarter, tape it to the end of your string. You will be creating your Uncle Bob in this step.
how much space should we leave between, like just at the edge? Should we make the quarter touch like that?
The same. I love your attention to detail. So if we were really, really careful, we would probably allow some extra length of our string to account for the quarter. I'll show you what I have. I have the string extending across the quarter and then taped it to there. So that'd be a good way to control this. Thank you for bringing that up.
Thank you.
When you're done taping, hold it up to the camera so I can see that you're good. It's like Mr. Rivera's good. The seam is good. Curly is good. Excellent. Okay. So this is where things are going to get a little tricky. Ideally, you'd be working in partners, and one of you could time while the other one holds the pendulum. But we're going to have you guys do this solo. So here's what this is going to. Here's what's going to. You're going to be holding the string at the opposite end, and you're going to be holding out the quarter at around 45 degrees. This is something that you can only really control to the best of your, you're just sort of ballparking this 45-degree angle halfway between vertical and horizontal. So that's how we're going to start this thing. And then here's how the timing is going to work. So have your timer out onto the stopwatch app. Obviously, you can't press start and let the quarter go at the same time because you don't have more than 2 hands. So here's how we've worked our way around it. What you're going to do is you're going to let the quarter go and oscillate once. So I'll just show you what that looks like. And once it gets back to its starting position, that's when you're going to press start on your stopwatch. When you press start, the time starts, obviously, and you're going to let it then go back and forth 5 times. So we're going to be measuring 5 period lengths here, and then we're going to be dividing by 5 and taking that out. So I'm just going to do this real quick. I just got a little knot in my stomach. Oh my goodness. You guys, I'm not sure who's worried. And we are set. So here, I got my timer ready to go. I'm gonna let this thing go. So I'm gonna start it now. That's 1 oscillation, 2 oscillations, 3, 4, and then 5. I'm stopping it at 5. I've got my time right there. I'm going to write down my time. And then once I'm done with that, I'm going to give the camera a thumbs up. So you guys just want to get 1 successful trial in here. If something gets messed up, you can do it again. Don't worry. Just give us a thumbs up when you are done with your first trial. So go ahead. See, you've got a thumbs up. Sure, you've got a thumbs up. Awesome. Okay, so we're going to be manipulating our independent variable now. Okay, we're going to start the timer. Great. Yep, okay. Record your data. Good. We've done all these steps. Now, we are going to be attaching 2 quarters. So just take another piece of tape and sandwich it onto your Uncle Bob and do the same exact thing. Write down your time with 5 oscillations, then with 3 quarters, and then with 4 quarters. Once you're done with 4 quarters, give us a big thumbs up and we can move on. This is going to take you a couple minutes. So just take your time and make sure you're getting the best data you can get. Mr. Rivera, should I put on some music while we're doing this?
That sounds like a good idea.
Okay. Anyone have any suggestions? I'm thinking the Jeopardy theme song.
I like this. Yeah, that works.
Here we go.
Oh, I have a question. So as we start going to like 2 and like 3 and 4 quarters, should we start putting the quarters on opposite sides of the string, or?
I was like sandwiching the string on the inside.
Yes.
That's a great question. I'm going to leave that up to you. I don't think it's going to make too much of a difference.
Got it. Thank you.
Yep.
Okay, so I'm just gonna move it ahead a little bit.
We were playing the Jeopardy theme song during this. I don't know why it's not coming through on the video, but it wasn't just me saying we're going to do it and then not doing it. FYI.
Hear it? Oh, it's coming through now.
Point.
Yep. I'll go back. No.
So let's talk data here. We are going to go to our data here. I'm going to start with, let's see, Wasim, do you want to be student 1 or student 2?
Give the ladies the honors, right? Student 1.
Okay, got it. Okay, here we go. All right, Wasim, for 1 quarter, which is 5.7 grams, that's what we have there. How many seconds was 5 periods?
So for the first 1 quarter one, I have 11.25 seconds.
Got it. Okay, for 2 quarters.
I have 11.3 seconds, 30.
Yep. Okay. For 3?
Again, 11.30.
Oh my God. For 4?
And then for this one, I got 11.25 again.
Wow. Okay. Shirley, student 1, what do we get for 1 quarter?
10.56.
10.56. For 2 quarters?
10.27.
7. 3 quarters?
9.36.
9.36. And 4?
8.7.
8.7. Got it. Okay. Let's go to Mr. Rivera. Go for it.
For 1 quarter, I got 10.14,
Mm-hmm.
10.27 seconds, 10.31, and 10.14.
0.14. Got it. All right. And then for mine, I got 9.73, 9.96, 10.03, and 10.00. Okay. So you guys all measured 5 periods. So in our spreadsheet here, we first take the average of all of these 5 oscillation timelines, and then we divide them by 4. So these 4 are the average periods that we all got taken together, and we have them graphed here on this graph. So what do we notice? I'm going to take it back here, and I'm going to, we have here we go, update. There we go. Okay, back to present. What do we notice? Who's got something to say?
There appears to be a trend
Tell us more.
downwards.
Seems to be a trend downwards.
Yeah, so as the ball gets heavier, the time that it takes to complete the oscillation decreases.
Mm-hmm. Okay. I certainly see why you'd
For the
say it.
average period decreases.
Wasim, what are you thinking here?
I think it's more like a plateau. It's overall staying the same, like 2 and like maybe 2.1. I think around the same. If we had more data points, it might be straighter.
Say more about that. Why would more data points make this straighter?
Right now, we only have 4 points, so we might have some outliers that might be influencing our data one way. But like the more points we have, like the more everything will be averaged out. And I think that might lead to a straighter trend.
Okay, so you said something about outliers. What would cause us to have outliers in our experiment that we just did?
Oh, so in something like this, I guess stuff like starting the stopwatch at the right time, or, not being sure like when the whole period completed before we mark the time down, and other variables like that.
So a lot of human error, you're saying?
Mm-hmm.
Okay, so with that in mind, Shirley, what do you have to say back to the team? Do you
Yeah,
agree?
I agree. Like for a couple of the data points, they were very close to each other. Like it's hard to say there's a significant relationship between that if they're that close to each other. Like they're off by like 0.1.
Yeah, definitely. Okay, yeah. Well, great job with this. We will see what happens in part 2 of our lab, and then we'll circle back afterward to look at everything. I'm going to give it to Mr. Ritter.
Thank you, Mr. Richter. Good job exploring the mass and how that might affect the period of a pendulum. And now we're going to be exploring how the length of the pendulum might affect its period. So we're going to be using the marks that we made in the step 1 of part 1 of the procedures. So we're going to keep all 4 quarters on the end of our string, right? Last time we held it at the 1 meter mark. This time we're going to be holding it at the first marker that we made. I'm going to be holding it at the 75 centimeter mark, and we will hold the quarter at 45 degrees to normal, same as the first part of the procedures. We're going to release the quarter, let it oscillate once. When the quarter reaches its starting position, we're going to start the timer, and then after 5 complete oscillations, we're going to stop the timer and record your data. So let's go ahead and do that for a string length of 75 centimeters, and let me get a thumbs up once we get our first data point. Nancy Shirley has her data point, Wasim has his data point, and so does Mr. Richter. Very good. So we're going to do that same procedure, but this time we're going to hold the string at the 50 centimeter and the 25 centimeter mark. So you're going to end this part 2 of the lab with 3 data points in total. So give me a thumbs up once you finish your other 2 data points.
Is this one version of the song?
Thank you very much. Shirley, I'm going to get my last data point. I'm lagging a little behind. Okay, I got my last data point. Very nice. So we are going to go back to our spreadsheet, and we are going to go to the change length portion. So we can see on our spreadsheet, on our table, that when the length is 100 centimeters, our data is already filled in. So what we're doing here is we're taking the data from the last lab, and we're going to transfer it over to measure what if we change the length of the string. So that's what we're doing here. And Shirley, let's start with you. What are the 3 data points that you got?
I have 7.98,
7.98,
6.86,
6.86,
and then 5.25.
5.25. Okay. Wasim, what did you get?
For 75, I got 9.81.
9.81.
For 50, I got 7.87.
7.87.
And for 25, I got 6.22.
6.22. Mr. Richter, what did you get for your data points?
For 75 centimeters, I got 8.84.
8.84.
7.19.
7.19.
And 5.04.
5.04. Okay. And what did I get? I got 8.97, 7.52, and 5.09 seconds. So This table works in the same way as described by Mr. Richter in the first part of the lab. We take the average of each condition, and then we find the period from the 5 oscillations. So let's take a look at this data that we have here and take a look at the graph that was made. What do we notice about this one? Can I get some hands? Wasim.
So in this one, the trend seems more like positively correlated, I think. Like, not, that's the wrong word, I'm sorry. It just seems to be not as straight as it was. Like the string size does seem to affect the oscillation period.
Okay, very good. When you said positive correlation, that is what's happening here, right? Shirley, do you have anything more you want to add on? Anything you want to say to Wasim or about what he said?
Yeah, I agree with his observation.
Okay, you agree with this observation. Very nice. So we can see here that there is a positive correlation between length of the string and average period. So using this information and seeing that there is a correlation here, what might we say about the aim if we were to revisit it? What determines the period of a pendulum? And what is that exact relationship? I need a volunteer. Wasim, what would we say here?
The length of the string determines the period of a pendulum. As the length of the string increases, the period also increases.
The period also increases. Okay, very good. So yeah, that we can clearly see that that's what's happening with our data here, that there is a positive correlation, and the length of the string does seem to determine what the period of the pendulum will be. So I'm going to hand this back to Mr. Richter now that we have established what the relationship is.
Very good. Thank you. So we're just going to introduce you quickly to your homework here. It is a worksheet where you're going to be graphing the period of a pendulum versus the length of the pendulum. We actually are going to give you the equation that determines the period. It's up at the top. T represents the period. You might think it should be P, but we typically reserve P for pressure. So in physics, once a letter is taken, we use a different letter. Then again, T is also temperature. So, I just figured I'd even say that. And you're going to be finding data points for 0 to 10. And there we have L is an element of, there's that fancy looking letter Z with a little plus at the end. Shirley or Wasim, do you know what that notation means?
Nope.
We don't use that in chemistry.
Got it. Yes. Yeah, that makes sense.
We use proton number for us.
So yeah, that's very good. So that's math notation for it's a set inside the positive integer set. So what this means is do not worry about calculating the period when length is 2.3 or anything like that. You're just going for the positive whole numbers from 0 to 10. And once you graph that, you are going to want to write a couple sentences about what exactly that mathematical relationship is between period and length. And we gave you a couple examples. Is it linear? Is it quadratic? Square root, inverse, sine, cosine? You'll just have to see for yourself and determine what you think it's going to be. So just to wrap up, let's do some fun vocab review. Wasim, what do you remember about the definition of a pendulum? Maybe you have it written down in your notes.
So would you like me to read it from my notes or say it in my words?
Let's have you say it in your own words.
Okay. So from like what we've done today and from what we've went over, a pendulum is basically, in my case, bobby root suspended from a string that oscillates.
Oh, you used another word. I like that. Yes. Okay. Look at that. Yes. In your own words, you pretty much summed that up. Coming to Shirley. Shirley, what does an oscillation mean?
So it would be the swing back and forth. Your
Yes.
your Bob or your Bobby, whoever it is.
Exactly. All right, coming back to Wasim, what is the definition of a period?
So the period is the time it takes for the I guess the bob to swing once back and forth.
Can you throw a vocab word in there?
Oscillate once back and forth.
Good. Okay. And now we are going to just do one little quick loop, and we're coming around again. Shirley, what is the definition of a pendulum?
When you have like an object suspended on a string,
And what is that object doing?
oscillating.
Very good. Okay. Yes. Speaking of that, let's come back to Wasim. Wasim, what does an oscillation mean?
Oscillations are the repeated back and forward movements of a bob on a string.
Nice. Good. And then, of course, Shirley, finish us out. What is a period?
The time it takes to complete a single oscillation.
Look at that. You guys are awesome. All right. Well, that about does it for Mr. Rivera and me. You guys were awesome today. Really, you did your best. You had some great predictions. You got some great data. Mr. Rivera, you got anything to say to our all-star students?
I just have to say you two did amazing today. Good job on the lab, and thank you for participating. It was very good.
Okay.
And Wasim, hope you can have maybe breakfast later tonight.
I will try my best. I've got some material ready.
Okay, let's stop sharing. Okay, so let's begin the critique. I'm going to record this. Okay. Okay, so we'll start with Brady or Samuel. Which one, what did you like about your lesson?
I can start with something.
Okay.
I liked waiting for visual feedback from the students to make sure that we were all on the same page. So asking them for like a thumbs up to make sure that we were all at the same point, and that would signal me or Brady to continue with the lesson.
Definitely. It was a good thing. Okay. Brady, what else? What did you like about your lesson?
This is something that I realized after the lesson, because Wasim told me, he said that he found it very fun, that it was such a hands-on, watching something go back and forth, pressing start and stop. So, you know, just this physical activity that you're doing it's hard to not be engaged by it.
Okay, good. Anything else that you liked about your lesson, you guys?
We try to make it fun, throw some wacky things in there, like naming your Bob, some kind of Bob derivative name.
Yeah, I thought that was great. That was really good. What would you like to do differently if you guys could do it again?
I would probably say change the summative assessment at the end to a more. It was good how every student was able to interact with with every vocab word, but I feel like something more fun could have been done as a summative assessment.
Right. So one of the requirements I wanted you to do is make it fun, have a game. And so, but it was effective in terms of like having each student go over those words. That was really important, but it could also be important and fun. So you could do something, you know, and I'm speaking to everybody, you could do something simple. Put out your hands, and if they guess the hand that has the Bob in it, then then the other person goes. Something really simple as that just gets a few more laughs going, a little more like, hey, this is not so serious, but it really is, because I'm really, as a teacher, I am really interested in what you know. But that vehicle, just keep, you know, something really simple. So that's definitely an improvement that you want to make next time. Okay, you guys, what do you guys like about the lesson? Okay, we'll go with Ashlyn K first, and then we'll go with Felix. Let's try to everybody try to make one comment, either what you liked or what you like to do differently. So try to aim for that. And I'm going to try to keep track, so I'll call on you if we forget. Okay, Ashlyn K, go ahead, and then Felix.
I thought it was really good how you guys explained what you were doing in the data table. So you were like, this is how we aggregated the data. I thought that was something that hasn't been done so far, like in this class. And I just thought you guys did a really good job explaining like why certain values were in those places in place of like having the students make the graphs themselves. I thought that was a really great move on your parts.
Okay, nice. Okay, Felix.
I thought you guys were super enthusiastic. And I really like that. You know, you showed, both of you showed that you love what you're doing, right? You love that you're teaching, and the students reflected that, obviously. You know, they were pretty engaged, at least from what I saw. And I think you guys did a good job with what Ashton said. The integration between the sheets and the PowerPoint was like really fluid. I think like, you know, being able to just update the table was like, and the graph was really useful. I think that was smart. So good job with that.
Yeah, nice, really, really nice graphing. Like the data table connection to the graph, everything in the spreadsheet really made things clear. It was really fast. Wasim, you have your hand up?
So I really loved like Brady and Sam's energy throughout the whole lesson. It didn't feel like they had a lot of authority being the teacher figures, but it also felt like we were in like the classroom with friends, and that just helped, you know, create a much more comfortable environment. Like no one was making fun of anybody. Everyone was just like out there having a great time, like vibing to the Jeopardy theme that you guys could sadly not hear.
So they really had a really nice presence, right? And you know, we're limited by Zoom, but they really came across as friendly, positive, outgoing. They were engaged, and so you know the audience is engaged. So that was definitely true. Okay, more comments that you liked about the lesson. What else did you guys like? Okay, Ashlyn H.
Going off of what Wasim said, I really liked how they used music. I feel like it can be really like dead space and very intimidating to have just like silence as the kids are
Mhm.
doing the work. Um, and one criticism is I don't know if Jeopardy was the right song because to me that's like a very pressuring song. Yeah, but I did like how they used music to like fill that dead air.
Yeah, so maybe future folks wants to use music when students are collecting data. That's a nice thing to do, right? So they're doing measurements and maybe something light, you know, in the background to make people a little bit more comfortable. Because remember when you guys were students and you know people are collecting data, and you kind of like you might not know what's going on. And you're looking over there and they're finishing up, and you're not, and you feel like the pressure. Okay, you don't feel comfortable. And so I think these teachers made us very comfortable. But I think, you know, anything that you can do when students are collecting data, say, hey, I got your back. I'm going to help you with your measurements if you need it. I'm going to play some maybe comfortable music. Don't worry about it. We're all going to go at different paces, but we're all going to get there at the same time. Okay. Because we're going to, like, if someone finishes up early, guess what they could do? They could go help a group that is lagging behind. So it's all a team. We're all here. So once you do that, it takes away the pressure. So that's a good topic that you brought up. Okay. About like when you're collecting data. Some people collect data quickly, other people don't. Some people are really careful and some people don't really understand the procedure. Your job during that point is to really intervene and help them. The place where you mellow out is letting them interpret and look at patterns. Okay. Okay, more comments. It's a really strong lesson. So what else did you guys like?
Going off of basically what everybody else has said so far, I thought it was really engaging. It felt like that atmosphere that was created was very fun and comfortable and safe. And I I felt that throughout the entire lesson, everything was very clear. Like there wasn't, you know, much ambiguity in like what the students should be doing. The directions were very clear, and they both made sure to check in on them and make sure that they were okay at each step and that they got each thing done. So I thought that was really important to have both of the like the comfort factor and then you know making sure everything's very clear at the same time. I think is very important, and I think they did a great job.
So Melissa, how many vocabulary words did they have?
3.
Right. And was that comfortable for you? Was that comfortable for you, Melissa?
Oh, I'm sorry, you broke up. Can you repeat that? Sorry, my Wi-Fi is very spotty.
Okay, were the 3 words comfortable? The number of words, was that comfortable for you?
Oh, I thought so. Honestly, I thought so. And somebody like myself who's not very like I always had a hard time with physics. I really understood the lesson and I really felt like if I was in that class, it would have really made a lot of sense to me.
Yeah, I wish my physics class was as clear as this lesson. You know, my previous physics, like, hey, why couldn't these guys be my teachers? Yeah, I mean, it's clear. The lesson is clear based on what the teachers are doing, but also based on the structure about trying to limit the number of new concepts. It's a big deal. It's a really big deal. I'm sure if Brady and Samuel introduced 6 new words, we wouldn't be saying the same things we're saying now. Okay. Anything else about what you liked? Anything else?
I agree with Melissa. I am someone who doesn't like physics. I'm just putting it out there. But I understood their lesson and, you know, the concept was very clear. So it worked for me.
Yeah. Yeah. They did a real classic experiment. Okay. It's been written up and you could do a lot of things with pendulums, not just that. So it's a rich area, it's inexpensive and it's safe. So it's a really good school mechanism. Shirley, you have your hand up?
I was just gonna give them a compliment. I thought what I haven't seen in the other groups is that that Samuel and Brady did really well was that they brought up sources of error, right? So if there was an error in your experiment, I think that it's really like educational to address it, and it's like it takes like 2 seconds to address. Hey, let's just think about where this error may have come from.
Yeah. Yeah, it's an interesting topic. So let's kind of move into what we'd like to do differently. And let's start with what Shirley said, like error. Specifically the graph. I mean, Shirley, you said there was like a downward trend. And then I think Wasim says, no, it's a constant trend. And they were talking a little bit about error and outliers. And so what would you guys, let's talk about that. Is that something that we want to change? Would that be something that you guys want to change individually? What do you, any comments about that? Okay, Felix, you have your hand up. Ish.
I was thinking this is just like an idea. Maybe when I did like the experiment, I think it was very accessible. But I know you guys did mention that, you know, like it's kind of rough, that 45-degree angle, so that might be an indicator of why the numbers were a little off. So a suggestion would be maybe ask students to get a protractor or something, so they could just, you know, have a good standard of like what's 45 degrees, because, you know, sometimes kids will just get like, oh, well, this is 45, right? It could be something else.
Okay. Maybe even a piece of paper that's cut, you know, on a 45-degree angle. It's going to help them to line it up a little bit. Okay. Any other comments about that? Okay, Caroline, go ahead.
I was wondering, and I'm not a physics person, so this is a really dumb comment, I'm sorry, but I was wondering if you could have taped the string to a wall and then just marked off where the starting point was. It's because I don't think the 45 degrees mattered so much as making sure you were starting from the same point each time, right? Because I one of the data sets did have a downward trend and all the others were bobbling around a little bit more. So I was wondering whether that might have solved that problem, so that, you know, they were always dropping the coin from the exact same spot.
Okay, let's
I
go
mean,
to
you have
John.
friction. I get that you have friction, but it's the same friction in each run, so maybe it wouldn't, like, maybe it wouldn't see data.
Okay, let's go to Jonathan and then to Shirley.
Normally for, I mean, more importantly, they did something really well in their in the entire lesson where they introduced theory in a comprehensive way and then brought in the math side of it, and it made sense. They tied the two together perfectly. And so when we're when they offered predictions and certain terms were thrown out, they tweaked them a little bit to actually match the terms in used for the formula for period of a pendulum. So that worked out really well.
Yeah. We're kind of backtracking into the positives, which is great. What Jonathan is saying is that, you know, introducing the equation, and it was very interesting how they did it. They introduced the equation for homework. And I agree with Jonathan. It made sense versus maybe introducing it in the body of the lesson. So I don't know, maybe by the end of the lesson, I was like, hey, I got this. And so when I saw that equation, I wasn't like, oh, whoa, what is that? I have to decipher it. So that's kind of a key point. Let's go to Shirley, then Wasim.
Like as you might have seen in the video, I really enjoyed their lesson. I had a lot of fun doing it. Like afterwards, when we like sort of debrief, I was like, wow, it felt so short because I was having so much fun. But I guess like one just tiny little thing I would change is maybe they can have like a pencil, tape the pencil to the desk, the student's desk, and then have the pendulum swing from there. And somehow you can like hook on a protractor if you want. Because one thing I noticed is that 1 meter is pretty long. Like for me, I was like, I was like out of the frame because I was really trying to hold it up and like all this jazzy stuff in the background that you couldn't see me try to do. So one thing would like either make the string a little shorter or just have it dangle off of like a pencil that's taped onto a desk.
So maybe
that's not on them, that's on that activity.
Right. So maybe kind of like find someone in the class, we'll say 30 people with the shortest arm span and go in a few inches and saying that's our full length. Okay. So we're starting with someone who could actually do it. So if a person with the shortest arm span, we find that we back in about a few inches, that's our furthest or longest piece of string. And then we go down from there. That could be, I like that idea, Shirley. You might, obviously, I like that technique. It's like getting better data and also making people comfortable that they could do it. Wasim, go ahead. You had your hand up.
Yeah, so I know Brady and Sam, they both addressed that this is normally like a 2-person experiment where one person would be timing while the other person would be doing the pendulum stuff. So like when we did get the trends and one of them did sort of trend downwards, I think they did a very good job like addressing that problem. Like they had us like talk to each other back and forth instead of addressing it themselves. So what could have been like a bad, they turned it into a really positive there.
Okay. So would you guys want to do this? If you're doing this in your class, would you like to have everybody do it working solo? Or do you want to work in teams of 2? What do you guys think? What would you like to do?
I think a group would be better because, you know, it engages everybody because there's always somebody maybe that doesn't understand what they're doing and they could have like a role model if somebody does. And, you know, the teachers could be walking around and at least it'll be more active, I guess, more engaging that way.
Okay. Anyone else? That's always kind of a thing. Like I have no problem. Like you could work in a team of 3, but then everyone does it individually. What I've seen in my life in terms of labs and activities, there's a lot of wallflowers, people who just like write down data. That's all they do. And everyone else does it. So my feeling is what I would do is probably have a small group that they could all like ask questions and all that between each other, but everyone does their own trials. Okay. Because it seemed to me from this experiment, it was totally possible to do that. Okay. It wasn't like, oh, I really need a timer. So just think about that. You're going to see a lot of wallflowers in your time. And your job is to like get them out and build confidence so they don't feel weird doing an experiment. Okay. What else would you like to do differently if you were doing it?
This is a really minor comment. And Wasim actually ended up doing it anyway, but they defined each term and then asked the question again. And I think they could have said, could you rephrase the aim in your own words using the different, right, the definitions of the terms that we just used, just to sort of really make sure that people aren't just repeating back the buzzwords and are understanding.
And so Caroline, you're talking about like when they did the answer to the aim?
No, at the beginning when they did the aim, they asked, can you repeat the aim? And I think you could have restated the aim using the definitions of the words rather than the words.
Okay, yep. I was also thinking when they were answering the aim, I think Wasim answered the aim, but I was like, hey, does Shirley really know? And I was thinking, hey, maybe they could ask Shirley to answer the aim and use her own words to answer it. So I think both your idea and also my idea in terms of like, hey, you have two students, check in with both. Okay. What other things did you like to change? You'd like to do differently a little bit? Anything else you like to do? Oh,
Okay.
Kavita, go ahead.
In the beginning, when they were asking to make predictions, I think Wasim used the word size of the string and Shirley used the word weight. Instead of telling them the scientific term, I think I would kind of guide them so that they can make the guess the correct word, like
Okay.
mass and length.
Okay. Okay. Anyone else about what you like to do a little bit differently?
I saw that we had a little bit of extra time, like the lesson, I think would for like 40 minutes. So maybe we could have done a few more trials to see like if the data stayed consistent.
Okay. Yeah, I would say that in terms of things that you might want to change, like science education is a journey to the already known. Science education is a journey to the already known. Scientists, their journey is to the unknown. Okay. And so we know we want to guide them to this relationship. We know that this relationship is very durable knowledge. It exists. It hasn't been refuted in years and years and years and years. And we're trying to steer them to something we already know. And so when it goes back to like, when Shirley said, hey, there's a downward trend. And in actuality, we know that Wasim said, well, it should be a constant. All right. And so, but I saw the downward trend too. One way to kind of manipulate that is instead of having the increments on the vertical axis go by 0.5, you might want to go by ones. So 0, 1, 2. What would happen is that downward trend would kind of tilt out a little bit and be a little bit more even. And so you would see that. And you'd say, well, Dr. D, you're manipulating stuff. You're kind of, well, this is a contrived experience. Science education is a controlled experience where we're visiting something that we already have discovered. And we're trying to be excited about it. We're trying to motivate, but we're not really doing like, cutting edge research. Okay. That's not really what it is. The idea of like error coming up, okay? The idea of error coming up. I was kind of battling with that idea. Like, do you talk about outliers and error and all that? And what I kind of came up with is that I think we should have the ability to do a 45-minute lesson where we have overwhelming data. We know it works. We worked out the procedure with like maybe the length and maybe using a protractor, but we have a really tight procedure where we get overwhelming data where we see a pattern. Okay. And there's not really many outliers, or if it is, we try to tighten it up for next time. Okay. So we're trying not to have a discussion because we're trying to do our lesson in 45 minutes and every minute is tight. We had a 40-minute lesson today with 2 people. In reality, you're going to have 25 people, 25 students, maybe more. And so every minute is really important to go down that road about error and uncertainty and outliers, I would say is problematic. At the same time, I also believe that we should also have a skill set where we can do maybe a 3-day lesson, a 3-day experiment, and we could get really into like what Wasim said, many more trials. And so in my class in 660, everyone has to take it except the bio people. Once again, I apologize because it was a little bit out of my control, but we really learn how to become good experimentalists, like rigorous. And we're taking, for this experiment, if it was done in 660, we would be taking for every different string, we would probably be taking about 10 trials. So we'd be taking about 40, 50 trials. Okay. We would be really rigorous. We'd be talking about, we would look at the uncertainty in the timer and how that connects to the final result, the whole bit. And there's a lot of different ways that we can really be rigorous. It's not taught in science education very often because it takes more time. So my feeling is like my solution is to know both. One, be able to do a 45-minute lesson. Don't get into error or uncertainty. Pick out experiments that really work and have a tight procedure that there's no like wiggle room. It's like everyone almost gets it. So it's like student proof. But on the other hand, I'm going to have my students maybe work on a project that spans a week where we're really going to be super rigorous, where it's going to be peer reviewed by students. It's going to be replicated by an independent group of students to see if you get the same thing. We're going to use secondary tests to make sure we confirm and validate our original findings. Okay, so to me, I like those both worlds, and that's how I kind of solved it. I'm not saying that's the only way to solve it, but it's something to think about where do you want to stand when it comes to that.
Can I say a positive that something you said made me think of? I was actually talking about my husband with this today. One thing I thought they did so well on this like idea of what kids are doing in science education is showing the person who originally found the pendulum and pointing out somebody who didn't have all of these fancy tools, right? Didn't have a computer, didn't have any context, and just noticed something weird and carried it through and proved something really important about our world. Because that to me is how you get kids interested in, like, pendulums as such are not that interesting, but that is so interesting. So I thought that was really cool.
Yeah, that's a really good point. Like, the insight and the quirkiness and the genius is it's weird. Like I have like a little quote by Jim Morrison of The Doors. It says, "Do you have the will to be weird?" And if you want to be creative and if you want to be, you need to be weird. And I'm just telling you, what is stranger than a gigantic pendulum? I don't know what else is strange. Like, how did this guy think about like, hey, I know pendulums, but let's see what happens when you have this gigantic one. And that's that creative leap. That something really cool happens from that. Okay. So I think Caroline, I kind of passed that over. And I think that's a really good highlight of this lesson. The other thing I said, so I think the weaknesses of the lesson is that try to maybe manipulate the vertical axis so that we try to get a horizontal constant relationship. I would ask, I didn't really understand, like you asked, I think Shirley was involved with like kinetic energy, what's the highest point and the lowest point, and then you got into the Earth rotating. So I didn't really see the connection between those two slides. Lastly, the vocabulary, the game of the summative assessment, make it fun. Those are the things that I want you to work on and consider. The other things that you did really great was Bob. Okay, that's fun. It was amazing. Little stupid things like that, I thought was like, that's great. Excellent graphics, history that Carolyn mentioned. Excellent voice and presence, fantastic. I like that you asked students to write this in their notes. Predictions were made. The materials you went through, does everyone have this? Does everyone have this? We're all on the same page. That was very well done. The aim was at the bottom. Nice. The data was very strong. Okay. It was very strong. So the activity worked. We understood it, like Melissa said. And then you also did something really cool that is very valuable in science called re-representation. When you have very large numbers or very small numbers, what you want to do is you want to tap into images that we all know. So you said like something about a football field, and you said something like a mass of a kid. Okay, that's like re-representing numbers that learners aren't really used to. It's kind of like light years or like super long distances. We're like, how long is that? Well, that's like traveling to New York to California, 10,000 times. Oh, that's long. Okay. So the re-representation of numbers you did, I thought I wanted to kind of emphasize that to something. I haven't really seen that happen very often, and I really did like it. Very strong lesson. Really good job. You guys should be super proud of yourself. You're headed, you guys are, we have 3 lessons and they're all A's and they're amazing and they're really strong. Can they be improved? Of course they can. Okay. So in your critique, I'm going to send you this video and you're going to look at it. I want you to think about the comments that you made, your peers made, and I made as you go through those tables in their critique. Okay. But once again, you made something. I was like, damn, I wish physics was as interesting and as understandable as this. And that's really to your credit. It was like I kind of call it like, it's like butter, right? It's just smooth. Okay. It's just like nice. I'm just understanding the pieces. The pieces are just moving together well. All right. So excellent work. I really was really super happy with that. So I'm going to stop recording. Okay. I will send you that. I will
Professor,
also make.
I actually have a question. One more thing about the lesson that we
sure.
just did, and addressing the error that was done.
Yep.
Would it be useful to have error bars automatically populate the graph from like a half range of our
Once
data?
again, you're putting something else, you're overlaying more information on the graph, and so you would have to explain that. You'd have to say, well, what does these error bars mean, and all that, which means a longer conversation. And so within 45 minutes, a little bit difficult to do. Once again, that doesn't mean I don't value error bars. I value them so much. I have a whole separate course, that's different from 713 from this course that totally emphasizes it. Right now I'm writing the book for the course. It's 2 volumes. One's called confidence and one is called uncertainty. So I'm down with uncertainty and error. And I think it's super important, but it's the context. It's the situation that that you're working with. All I'm saying, Samuel, is when you're working with 25 kids to get this lesson that you did, you might only have to focus on one of those variables. Okay. You're going to be pressed for time. And so, but at the same time, if you guys want to turn this into like a week project and get into uncertainty and error and all that, I would definitely do that. Okay. All right. So, what you guys, like I did for the previous teams, I'll send you this critique. I will send you the grade for this lesson. And I also will send you a grade for your lesson plan. All right. Maybe, and if it's something that you could do to make it better, I will tell you. Okay. So sometimes I will ask you to redo it. Sometimes I'll give you like an A- or a B+, and I'll say, well, if you want to change it, if you want to improve it because you missed this step and missed that step, you can improve it and send it back to me and I'll give you an A. Okay. So I'm kind of more interested in you, being reflective and improving things. To me, grades are not as important at all compared to becoming a really good teacher when you leave Hunter, like getting off on the right track when you get your full-time job. And you know a lot of things. You're not going to know everything what to do, but you're headed in the right direction. It's all about being a good teacher. So the grades are kind of there to motivate you to kind of improve, but they're really not the focus of what I'm about in terms of being here. It's really about what are the skills I need, what's the understanding I need, the abilities I need to get on that road of being a great teacher. Okay. Okay, cool. I'm going to talk to, I guess I'm going to talk to Shirley and Wasim just after this. Do we have any closing questions or concerns? Okay, cool. That kind of tells me that you guys we're getting into the routine. We're getting into, this is what we're doing week after week. Okay. It might not be your time to do the lesson, but it's your time to help those guys who are teaching. And so we're starting to feel comfortable. We're at the level that I want you to be at, and we're headed in the right direction. Everything is going very well. So, and that basically, that responsibility kind of came with the trailblazers who kind of really led the way. And now we're beyond them. Now we're like we're in the middle. So keep on working hard, keep on, learn from these lessons that you've seen. And everything is, I'm really impressed so far. This is really going well. And your lack of questions right now just kind of tells me that, yeah, you're getting into it. You know what we have to do. You know the objectives. You know where we're headed. All right. So once again, enjoy the break. I'm going to do attendance really quick. Once I call your name, you can log out. Have a wonderful spring break. I will not see you next week. I will see you the week after. Okay. Stacy.